Hi everyone, welcome. Today we're going to be doing Leetcode problem number 19, removing the nth node from the end of a list. So the problem states, given the head of a linked list, remove the nth node from the end of the list and return its head. So the way we think about this intuitively is that we want to set let's say we want to remove this node number 4. We would then go to the previous node and then set that node's next pointer to 5. Okay, so we would set 3's next pointer to 5, and then that would exclude 4 from the linked list. That is essentially how we remove a node from a linked list. However, we can't do that here because it's saying the nth node from the end of the list, not from the beginning. And with linked lists, we don't know the length of the list. And it's not really indexed in the same way that an array is, for example. So we can't just say, okay, remove the nth index or something. So what we have to do is either go through, find the length of the linked list, and then go through again until we get to the length of the linked list minus n plus 1, so that we're at 3, not just 4, and then go ahead and set that next pointer to next.next. That works, but a faster way that we could do it, where we only have to do one pass, is basically setting up 2 pointers where we have a slow pointer and a fast pointer, and we set the fast pointer to be, the distance between the fast and the slow pointer is always going to be n plus 1, so that when the fast pointer hits the end of the list, the slow pointer is in the position right before the node that we want to remove, and then we can go ahead and set that slow pointer's node, we set that node's next pointer to node.next.next, if that makes sense. So I'm going to go ahead and kind of draw this out for you here with this list. So let's say this is our original linked list. We want to go ahead and set up a dummy pointer here. Sorry, we missed the 4 here. So we want to go ahead and set up a dummy pointer that's pointing to the head. And then we'll start out 2 pointers here, a slow and a fast pointer. And they're both pointing to this dummy node, okay? Then we want to accelerate our fast pointer up so that it is n plus 1 spots ahead of the slow pointer. So in the case where n is 2, we want this to be in 3 spots ahead of the slow pointer. So 1, 2, 3, that puts us at this spot, okay, where our fast pointer is at this spot, and then our slow pointer is still at the beginning. Then we'll go ahead and we'll iterate both of them at the same time, so they're moving at the same pace, until we get our fast pointer to the end of the list, which will mean that our slow pointer is at the spot right before the node that we need to remove. So we're just going to mark this as red because we want to remove the second node from the end. So then we'll go ahead and we'll move our both slow pointer and fast pointer up by 1. So after one iteration, this is where they're going to be. After a second iteration, this is where they're going to be. And then after a third iteration, the fast pointer is now past the linked list, so it's pointing to a node that doesn't exist, and our slow pointer is pointing to the node right before the node that we want to remove, which is perfect, because now we can set this node's pointer to next.next, which is 5, and that will go ahead and cut out 4 from the list, and then we have our new linked list without the second node from the end, okay? So let's go ahead and type that up here. So we want to start out with a dummy node. This is just a way that we can, manipulate a linked list without changing the original list. So we'll say that the dummy node is pointing to the head. And then we'll set up a slow pointer, which is pointing to the dummy node, and a fast pointer, which is also pointing to the dummy node. With linked lists, we kind of use nodes as opposed to indices with arrays and array lists and things like that. So we'll go ahead and first we'll move that fast pointer to the spot that we need it to be at. So we'll say for x in range n plus 1, because we want it to be n+1 spots away from the slow pointer at all times. We're going to say fast equals fast.next, okay? Then once we have our fast pointer in the spot that we need it to be at, we'll go ahead and iterate both the slow and the fast pointers at the same pace, okay? So we'll say while fast exists, because remember our stopping condition is when fast is past the linked list. So it's finished with its, nodes and it's past the last node. So we'll say while fast exists, slow is going to equal slow.next, and fast is going to equal fast.next. Okay, so we're iterating them, incrementing them at the same pace. And then we will say once fast is past the last node, that means that our slow pointer is going to be at the node right before the node that we want to remove. So we can go ahead and we can set our slow.next pointer to equal slow.next.next. So it's skipping that slow.next. And then we can go ahead and return dummy.next, which is basically the head of the new list. And we'll go ahead and run that code, make sure that works. And it does, and then we'll submit it, and it also is accepted with all the submissions. So there you go. That is how you do the Leetcode problem number 19, removing the nth node from the end of a list. Hope that helps.